In this session, we shall look at the conclusive part of important problems in definite integrals. In this connection, let us observe the function, the problem, that f of x, capital F of x is equal to integral 0 to x square of f of t dt. If this capital F of x is equal to x square into 1 plus x, then what is f of 4? That is the question. You follow the question carefully. Capital F of x is equal to integral 0 to x square of f of t dt. And if capital F of x is equal to x square into 1 plus x, then f of 4 is, well, let us try. F of x is equal to integral 0 to x square f of t dt is equal to x square into 1 plus x. That is, of course, x square plus x cube. Now, let us differentiate this part on both sides with respect to x. The derivative of this by using the Lagrange's rule, it is f of x square into derivative of x square is 2x is equal to, their derivative of x square is 2x and derivative of x cube is 3x square. Okay, by cancelling 2x on both the sides, what are you going to have? F of x square is equal to 1 plus 3x square by 2x. These are nothing but 3x by 2. Okay then, this is f of x square. Well, what are we required? F of 4, isn't it? Well, so as f of 4 is required, you take x is equal to 2 in this last step. What do you have? F of 2 square is equal to 1 plus 3 into 2 by 2, isn't it? So f of 4 is therefore equal to 2 and 2 go away, leaving you 4. What is f of 4? 4. Well, my dear, here in this process of differentiating, we could have made use of the Lagrange's rule of differentiating integral 0 to h of x of f of t dt is f of h of x into h dash x. I think you might have recollected the so-called Lagrange's rule of differentiating a definite integral like this. And in the place of h of x, we could have had x square here. Hence, it is f of x square into h dash x. H dash x is nothing but 2x. Hence, we could have had f of x square into 2x is equal to 2x plus 3x square. By cancelling 2x, we will be having f of x square is equal to 1 plus 3x by 2. Thereby, f of 2 square is equal to 1 plus 6 by 2, that is 4. Hence, the answer is 4. This is the question. You please follow it. Observe this question. It is absolutely similar to the previous one. Again, here also we are supposed to make use of Lagrange's rule of differentiation. Okay. He has given that integral 0 to t square of x into f of x dx is equal to 2 by 5 into t power 5. Then what is f of 4 by 25? F of 4 by 25. Good. This is the data. In the data, integral of x into f of x is given, and in the requirement, we are just supposed to have f of. There itself, we can get the idea of differentiating this step on both sides. Come on, do that. This is t square into f of t square into 2t by using Lagrange's rule is equal to 2 by 5 into 5t power 4. 5t power 4. 5 and 5 will go away. What happens? This is f of t square into 2t cube is equal to 2t power 4, isn't it? 2t into t square is 2t cube, 2 into t power 4. Now let me cancel 2t cube on both the sides. What do you have? F of t square is therefore equal to 2t cube will be cancelled, leaving you t. Now you replace root x in the place of t. What happens? f of t square is equal to t. Now let me take t is equal to root x. Then f of x is equal to root x. F of x is equal to root x. But here we are asked to have f of 4 by 25, isn't it? F of 4 by 25, and you replace x by 4 by 25, so that it is root of 4 by 25, hence it is 2 by 5. Therefore, the answer is 2 by 5. Here also, in this question also, we could have made use of Lagrange's rule of differentiating a definite integral. Here, in the place of h of x, we have t square here. F of that into h dash x is nothing but 2t. I could have cancelled 2t cube on both the sides, leaving you f of t square is equal to t. And now, we want to have 4 by 25. You can take t as 2 by 5 or t as root x also, so that you may be having a formula for f of x also. So f of x is equal to root x. Here f of 4 by 25 is required, hence it is a root of 4 by 25, hence it is 2 by 5. It is 2 by 5. If for the question, it's a beautiful question. If f is differentiable, f of t is equal to 6 and f dash 2 is equal to 1 by 48, then limit as x tends to 2, integral 6 to f of x of 4t cube dt by x minus 2. See, limit as x tends to 2, he is asking, if you replace x by 2, 6 to f of 2, what is f of 2? 6. 6 to 6 means it is 0. Numerator is in the form 0, 2 minus 2 is 0. Happy to see that it is in the form 0 by 0. Then and there itself we will have the right of using L'Hospital's rule. By using L'Hospital's rule, this is equal to limit as x tends to 2 of d by dx of integral 6 to f of x of 4t cube dt by d by dx of x minus 2. By making use of L'Hospital's rule. Well, this is equal to, again by using Lagrange's rule, this is nothing but 4 into f of x whole cube into f dash x by its derivative is 1. Of course, here we should not omit this limit. Limit as x tends to 2 is equal to, it is straight, it is straightly very simple aspect, no question of any 0 by 0 form. You just replace x by 2 so that it is 4 into f of 2 whole cube into f dash 2. Luckily we are given about f of 2. What is f of 2? 6. Hence it is 4 into 6 cube into, what is f dash 2? 1 by 48. 1 by 48. Hence it is 4 into 6 into 36 into 1 by 48. 6 4s are 24, goes 2 times. 36 by 2 is of course 18, hence the answer is 18. Whenever the problem in which Lagrange's rule is to be used to get it simplified and to estimate the correct answer. Please go through the answer. The next problem before us is integral 0 to 64 fractional part of cube root of x. Integral 0 to 64 fractional part of cube root of x. I think we all know this symbol is meant to represent the fractional part of a real number x. Okay, let us recall the concepts regarding fractional part and integral part. You see, for any x, x is equal to integral part of x plus fractional part of x, isn't it? integral part of x plus fractional part of x. For example, say x is equal to 2.13. Then integral part x is 2, fractional part is 0.13. If you add them, you'll be going to get x, isn't it? Well, from this, fractional part of x is equal to x minus integral part of x. We can recall. Well, let us make use of that here in this context. This is equal to integral 0 to 64. Come on, friend. Fractional part of cube root of x. How can we write? By making use of that concept as rather the definition. Integral part of cube root of x, no sorry, fractional part of cube root of x is cube root of x minus integral part of cube root of x dx. Isn't it? Okay, now let me split this into two separate integrals. Integral 0 to 64 cube root of x dx minus integral 0 to 64 cube root of x, integral part of cube root of x dx. Well done. This is x to the power of 1 by 3 integral 0 to 64 of this minus, come on friend, integral part of cube root of x. It changes at various places between 1 cube and 2 cube, rather 1 and 8, integral part of x is 1. Oh no, sorry, from 0 to 1 it is 0. Between 1 and 8 it is 1. From 8 to 27 it is 2. From 27 to 64 it is 3. Like that you can split. What I mean to say is minus integral 0 to 1 cube root of x, integral part of cube root of x dx plus integral 1 to 8 integral part of cube root of x dx plus integral 8 to 27 integral part of cube root of x dx. At last, from 27 to 64 integral part of cube root of x dx. Let us look at the first part of this integral. What is the integral of x power 1 by 3? X power 1 by 3 plus 1 by 1 by 3 plus 1. 1 by 3 plus 1 is 4 by 3. Hence it is x to the power of 4 by 3 by 4 by 3 between the limits 0 to 64 minus, come on friend, between 0 and 1, what is cube root of x? 0 point something. Hence its integral part is 0. Therefore, integral 0 to 1 of 0 dx plus integral 1 to 8. Come on friend, cube root of x between 1 and 8, what will it be? It will be 1 point something. Hence its integral part is 1 dx plus integral 8 to 27. Between 8 and 27, integral cube root of x is 2 point something, isn't it? X lies between 8 and 27. So x is suppose 8 point something, then cube root of that is 2 point something. Hence entirely this cube root of x is 2 point something. Hence its integral part is 2. Hence it is 2 dx. And at last, with the similar type of discussion between 27 and 64, cube root of x will be 3 point something. Hence its integral part is of course 3 dx. Good. Let us simplify this. 4 by 3 becomes 3 by 4. 64. 4 cube power 4 by 3. Minus 0 power 4 by 3. This is 0. Integral is also 0. Forget it. Plus 1 into 8 minus 1 plus 2 into 27 minus 8 plus 3 into 64 minus 27. Well done. What happens to this? 3 and 3 go away. 4 power 4 by 4 is 4 cube. 4 cube is 64. 3 into 64 is 3 into 64. 3 60s are 180. 3 4s are 12. 192 minus, come on, 8 minus 1 is 8. 7. 7 1s are 7. 27 minus 8 is 19. 19 2s are 38. Plus 64 minus 27 is 37. And 3 37s are 111. Let us get it simplified. 38 plus 7 is 45. 45 plus 11 is 56. It is 156. 192 minus 156. 192 minus 156. So the answer is 36. That is the ultimate answer. You look at that. You please observe the style of splitting this integral. The very first concept that you must use is fractional part of cube root of x is cube root of x minus integral part of cube root of x. And we could have split this into two integrals. This is the first integral, that is the next integral. Okay, this is of course the direct integral. For x power 1 by 3, you can have it as x power 1 by 3 plus 1 by 1 by 3 plus 1, that is 4 by 3 by 4 by 3. And you have observed the style of simplifying it. And of course, about the second integral 0 to 64, the function inside this bracket is cube root of x. You please observe the stages at which this cube root of x changes. Between 1 and 8, between 0 and 1, it is 0 point something, hence its integral part is 0. Between 1 and 8, it is 1 point something, hence its integral part is 1. And between 8 and 27, that is 2 cube and 3 cube, isn't it? 0 cube and 1 cube, 1 cube and 2 cube, 2 cube and 3 cube, 3 cube and 4 cube. 64 is nothing but 4 cube. So at regular intervals, it changes the shape. Therefore, like this, we could have split it, and thereby we have seen that the process of integration has been made very simple. The ultimate answer is that. You please follow the question. No doubt it is a beautiful question. Let us have one more such question. Integral 0 to 64, fractional part of root x. Fractional part of root x. Well, even in the previous question, we could have made use of the definition of fractional part. Fractional part of any x is of course x minus integral part of x. Basing on that, we will be able to write this step as integral 0 to 64 root x minus integral part of root x dx. Am I correct? Again, this takes into two forms of integrals. What are they? Integral 0 to 64 of root x dx minus integral 0 to 64 of integral part of root x dx. Okay. Integral part of root x. What is the integral part of root x? Sorry, what is the integral of root x? 2 by 3 into x root x between the limits 0 to 64. Am I correct? Root x means x power half plus 1 by half plus 1. Half plus 1 is 3 by 2. If it comes to the numerator, it becomes 2 by 3. 2 by 3 into x power half plus 1 is x power half into x power 1. That is x root x between 0 and 64. Well done, my dear. This is the right time to split this integral. Now you tell me the boundaries at which root x changes. 0 square to 1 square, 1 square to 2 square, 2 square to 3 square, 3 square to 4 square, 4 square to 5 square, 5 square to 60 square, like that up to 8 square. 8 square you must have. What is that? Integral 0 to 1 integral part of root x dx plus integral 1 to 2 square, that is 4, integral part of root x dx, plus integral 2 square to 3 square, that is 9, integral part of root x dx, plus etc 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 etc. But with the last one, 7 square, that is 49 to 64, integral part of root x dx. Like that we may have to split it, because the function which lies inside the brackets is root x. So it changes at regular intervals, that is that's 1 square, 2 square, 3 square, 4 square, etc. up to 8 square. That is why we could have split that integral as the sum of these integrals. Well done. Let us see. This is 2 by 3 into. If you put 64 into root 64. What is root 64? 8. 8 into 64. That is 2 power 6 into 2 cube. 2 power 9, 502. 512 into 2. That is 1024. Let it be minus. Come on, tell me. Integral 0 to 1. What is integral part of x between 0 and 1? It is 0 plus between 1 square and 2 square. Integral part of root x is it is 1 point something, isn't it? Hence its integral 1 to 4 1 dx, 4 to 9 2 dx, like that, etc. What will be the last one? It is integral 49 to 64 7 dx. Okay. Now the process of simplifying this is only remain. What is 2 into 512 by 3? It is 1024 by 3. 1024 by 3 minus. Come on. The first one is 0. Forget it. Plus 4 minus 1 plus 2 into 9 minus 4 plus next 4 to 9 and then 9 to 16. 16 minus 9 plus 4 into 16 to 25. So 25 minus 16 plus 5 into 25 to 36. 36 minus 25 plus 6 into 36 to 49. 49 minus 36 plus 7 into 49 to 64. 64 minus 49. This is the answer. 1024 by 3 minus etc. etc. And the thing remind there is after all a numerical calculation, you can easily do that. This is the process of getting it. Previously we could have had cube root of x here, so that the number of divisions is somehow less when compared to that of this case. 8 steps are there. 0 square to 1 square, 1 square to 2 square, 2 square to 3 square, 3 square to 4 square, like that, up to 8 squares. But in the previous case, we could have had 0 cube to 1 cube, 1 cube to 2 cube, 3 cube to 4 cube. That's all. As it was the case with cubes, but here this is the case with squares. So number will automatically be increased. Well, let us simplify that one. 1024 by 3 minus of 3 plus 10 plus 21 plus 36 plus 36 minus 25. We can do what is that. So to observe the simplified form of that one, I would like to cancel these steps. You please follow once. That is equal to 1024 by 3 minus 4 minus 1, 3. 9 minus 4, 5. 5 2s are 10. 16 minus 7, 9, 7. 7 3s are 21. 25 minus 16, 9. 4 9s are 36. 36 minus 25 is 11. 5 11s are 55. 49 minus 36 is 9. 9 6 are 54. 64 minus 49 is 15. 7 15s are 105. So that this is 1024 by 3 minus, add all of them. 5, 9, 14, 20, 21, 24. 2, 7, 12, 15, 17, 18. 1 plus 1, 2. This is equal to 1024 minus 3 into 284. You subtract 3 16s of 3 4s are 12, 3 8s are 24 plus 1 25, 3 2s are 6 plus 2 8 by 3. That is the answer. And the numeral answer is not important, is not the main issue here. The way in which you split the integral is very important. Well, let us follow the next question. Let us look at the next question. This is a matter in which there has been a connection with two types of functions, namely f of x and g of x. F and g are of course differentiable functions of x. It has been given that f dash x is equal to f of x. This is the important point to be noted here. F dash x is equal to f of x. And f of 0 is equal to 1 and f of x plus g of x equal to x square. Well, my dear friends, as and when you look at the condition that f dash x is equal to f of x, you please remember that f of x is equal to some constant into e power x. What is f dash x? You look at a into e power x. No change at all. No change at all, isn't it? Therefore, f of x is of this model. F of x is equal to a into e power x. And this is, of course, the key step here to be remembered. That can be used as and when we look at the condition f dash x is equal to f of x. Wherever you look at that condition f dash x is equal to f of x, you can be in a position to make use of the fact that f of x is equal to some constant into e power x. Now, it is our need, of course, to have a. How can we get a? It's very simple. F of 0 is 1 he has given, isn't it? What does it mean? A into e power 0 is equal to 1. E power 0 is 1, hence a is equal to 1. As a is equal to 1, you can directly take f of x is equal to e power x. F of x is equal to e power x. Well, friend, let us now think of g of x. What is g of x? G of x is equal to, but g of x is equal to x square minus f of x. So it is x square minus e power x. Because f of x is e power x, what is g of x? X square minus e power x. But you see, we are asked to have integral 0 to 1 f of x into g of x, isn't it? Integral 0 to 1 f of x into g of x. What is f of x? Is equal to integral 0 to 1 e power x into x square minus e power x dx. Hence, it is integral 0 to 1 x square e power x dx minus integral 0 to 1 e power x into e power x e power 2x dx. And it is in no time, of course, we can be in a position to have the answer directly. Of course, here by using integration by parts, we can have it. How can we have? Let us observe the steps. Those steps also. Well, I like to remove these steps. You please follow once. So it is x square into e power x minus 2x into e power x plus 2 into e power x between the limit 0 to 1. Why is it possible to have the answer directly? there has been a certain hint regarding such type of product of functions. X square is f of x, e power x is second function. X square, its derivative. Integral of e power x, its integral. This product minus this product plus this product, isn't it? In the early days of learning integration by parts, we were able to have this technique, a rather easy procedure, isn't it? By basing on that, we are in a position to have the answer for the first integral like this. Minus, what is the integral of e power 2x? E power 2x by 2 between the limits, of course, 0 to 1. Good. Again, this is e power x into x square minus 2x plus 2 between the limits 0 to 1. Minus, you substitute 1 in the beginning, e square by 2 you have. Substitute 0, e power 0 is 1 by 2. Substitute 1 here in the beginning, e into 1 minus 2 plus 2. 1 square minus 2 plus 2. Minus, substitute 0, e power 0 is 1, 0, 0, 2, 2. Minus e square by 2 plus 1 by 2. All together, it is e minus 2, e minus e square by 2 minus 2 plus half. What is minus 2 plus half? Minus 3 by 2. Hence, this is e minus e square by 2 minus 3 by 2. This is, of course, the original answer. You please follow it. Let us look at the next question. The question itself looks very lengthier. Question looks so lengthier. Answer is very simple, of course. He has given the options also. The answer is in terms of I, either 2i, 3i, 6i, 8i, something like that. What is that? First of all, let us read the items given in the data. T greater than 0 is a positive constant, of course, and f is a continuous function such that f of x plus t is equal to f of x for all x in the domain. What can you understand by that? F of x plus t is equal to f of x means t is the period of f of x, isn't it? Okay, in the domain of f of x. I is equal to integral 0 to t f of x dx, then integral 3 to 3 plus 2t of f of 2x dx. How much? He is asking. And options are also given. The options are 2i, 4i, 6i, 3i, none, like that he is asking. Okay, let me suppose, let j is equal to integral 3 to 3 plus 2t of f of 2x dx. That is the required integral. I like to suppose it some j, because I is given, and moreover, the crucial part here is to understand the nature of options given. What are the options? 2i, 3i, 4i, 6i, like that. So answer is in terms of i's. What is I? Integral of f of x. So f of one particular parameter, one particular variable must be there. Here it is 2x. Okay, we have got the idea. What is that idea? Let 2x is equal to t. Then 2 dx is equal to dt. Implies dx is equal to half dt. Also, let us change the limits here. These limits are corresponding to 2x, corresponding to x rather, but we have introduced a new variable t. So, we have to find the limits corresponding to t. What happens? If x is equal to 3, that is the lower limit 3, then what happens to t? T is equal to 2 3s are 6. If x is equal to 3 plus 2t, then what happens to t? 2 into 3 plus 2t is 6 plus 4t, isn't it? X is equal to 3 plus 2t means it is 6 plus 4t. 6 plus 4t. Come on friend, what happens to j? J is equal to, previously the limits were 3 to 3 plus 2t. Now the limits are 6 to 6 plus 4t. Of f of 2x means f of small t. Dx means half dt. This is equal to half into. I would like to write this as 4 into integral 0 to t f of t dt. I mean it. I want to write it. How is it possible? How is it possible? What formula or what fact I could have made use of? Yes, let me recall this. Let me recall the formula. What is the formula? If f of x is a periodic function with period t, then integral a to a plus nt of f of x dx is just nothing but n into integral 0 to t f of x dx. It is a valuable formula. Rather a fact it is. Integral a to a plus nt of f of x, of course t must be the period, is nothing but n into integral 0 to t f of x dx. Well, come on, what are the figures here? In the place of a we have 6, in the place of n we have 4, in the place of t we have t itself. By making use of this only, we could have got this result, half into 4 into integral 0 to t f of t dt. I think you could have understood. What is the final answer? 2i. What is the final answer? It is 2i. Half into 4 is 2. Integral 0 to t f of x dx is given to be I. Final answer is 2i, and you choose that option in which 2i is present. Hence the answer is 2i. No doubt it's a beautiful question. You follow it. Let us now observe this question. For this question also, there has been a lengthier data has been given. Let us try to make use of the essence given in the data. A cubic polynomial f of x. Okay, we can understand that f of x is equal to some ax cube plus bx square plus cx like that. It vanishes at x minus 6 is equal to minus 2. So, first of all, the meaning of the first line f of minus 2 and has local maximum or minimum at x is equal to minus 1 and x is equal to 1 by 3. It does mean that they are at stationary points. So f dash to minus 1 is 0 and f dash to 1 by 3 is also 0. So we can take f dash x is equal to a constant a into x plus 1 into x minus 1 by 3, isn't it? X plus 1 into x minus 1 by 3. So this is equal to a into x square, x into minus 1 by 3 minus x by 3 plus x minus 1 by 3. So that this is a into x square, x minus x by 3 is 2x by 3 minus 1 by 3. This is f dash x. This is f dash x. I could have made use of the first 2 lines of data only so far. The data, there are 3 lines, you see. In the first line, he is saying that f of x is a cubic polynomial which vanishes at x is equal to minus 2. What can you say? F of minus 2 is 0. F of minus 2 is 0. Okay, and f dash x is equal to a into x plus 1 into x minus 1 by 3. How can you make use of that? If he says that f dash x vanishes at x is equal to minus 1 and x is equal to 1 by 3, isn't it? So f dash to minus 1 is 0. So x plus 1 is a factor of f dash x. Similarly, x minus 1 by 3 is a factor of f dash x. Moreover, f is given to be a cubic polynomial, hence f dash x must be a quadratic polynomial, hence it can be written as a into x plus 1 into a into x minus 1 by 3. Okay, this is f dash x. Good. And next one, plus b might be there. This is f dash x. Now we are to make use of the essence of third line of the data, that is minus 1 to 1 f of x dx is equal to 14 by 3. How can we make use of that? Integrate this. What happens? F of x is equal to a into x cube by 3 plus 2 by 3 into x square by 2, that is x square by 3 minus x by 3 plus b, plus a constant b. You see, but f of minus 2 is equal to 0, he is saying. F of minus 2 is 0, he is saying. What happens? Implies a into minus 8 by 3 plus 4 by 3 plus 2 by 3 is equal, plus b is equal to 0. You see, 4 plus 2, 6. 6 minus 8 is minus 2. Minus 2 by 3. Okay. Therefore, b is equal to 2a by 3. Am I right? b is equal to 2a by 3. By making use of this, we will be able to have, you see, b. This is 6 minus 8 is minus 2. Minus 2 by 3 into a. If it goes that side, what can you have? b is equal to 2a by 3. We have got b is equal to 2a by 3. Let us make use of this b to estimate f of x. Therefore, f of x is therefore equal to a into x cube by 3 plus x square by 3 minus x by 3 plus 2a by 3. So that it is a by 3 into x cube plus x square minus x plus 2. This is f of x. By making use of every piece of the data, so far we are able to get b. But still there is an unknown a. How to get that a? To get that a, there has been another information in the third line of the data in the beginning of the question itself. What is that? What is that? Integral, but integral minus 1 to 1 of f of x dx is given to be, what is that? It is given to be 14 by 3. 14 by 3 implies, what is integral of this? A by 3 into integral of f of x. X cube is x power 4 by 4. X cube by 3. X square by 2 plus 2x. Between the limits minus 1 to 1 is equal to 14 by 3. Is equal to 14 by 3. You can cancel 3 and 3. Now we are ready to have the value of small a. Now I remove this part. A into, if you put 1 by 4 plus 1 by 3 minus 1 by 2 plus 2. If you put minus 1 by 4 minus 1 by 3 minus 1 by 2 minus 2 is equal to 14. 1 by 4 minus half, total a into 1 by 3 plus 1 by 3, 2 by 3, 2 plus 2, 4 is equal to 14. Therefore, a into 12 plus 2, 14, 14 by 3 is equal to 14. Thereby we will be getting a is equal to 3. Success! We have got both a and b, so that we will be able to estimate f of x. What is f of x? F of x is therefore equal to 3 into, this is, in the place of a you take just 3, 3 by 3 is 1. F of x is therefore 3 by 3 is 1, x cube plus x square minus x plus 2. But the main question, you see, we are asked to have f of 1. What is f of 1? F of 1 is therefore 1 plus 1 minus 1 plus 2, it is 3. Ultimately the answer is 3. The main part involved in the solution is you are to get small a and b by making use of the pieces of information in the data. Then only you will be able to have f of x and thereby f of 1 as 3. That's it.